Hello everyone, welcome to Coder and Boots. So in this video we are going to discuss about the topic how to run a Python program as a daemon in a Linux machine. Okay, so before getting into this topic we need to have a basic understanding of what a daemon is, okay, or what a system service is. Because when we develop application, so we usually run it from our laptop or a computer by directly executing the command python that application code.py, or maybe like by using our IDE. But have you ever thought like how you will run this application when you run from or when you deploy it in the production? So in the production nobody is there to restart manually or to start the service manually. So you'll need a mechanism to run this automatically as per the system, within the system. So that means whenever the system starts, this your program will get started automatically. Whenever the system restarts, that time also your program will get started automatically. Or if there is a, let's say, a failure, okay, so it should restart. So all these we can configure it through a daemon process. Okay, so there is a mechanism in the Linux. So in Linux we have so many daemons, so we can say Linux is a world of daemons, and we can create a custom daemon for our Python program. So daemon is also called as service. Okay, so a system service. So maybe you can use the keyword daemon or a system service. Okay, so this is a kind of a very useful tip for your programming journey. So these are the following topics that we are going to cover in today's session. So one is what's a daemon. I mean we already discussed about it. Why is it required? Okay, so this is required, let's say like you are deploying your application in production. As we discussed, it has to run automatically. Okay, so without the intervention or without a human intervention, the program has to run. Okay, and then also let's say sometimes recently there was a major outage in most of the cloud service, one of the popular cloud service provider. So what has happened is there were reboots associated with that. So most of the servers got rebooted. So when you reboot a server, or there will be monthly patch I mean installations happening in most of the servers. Okay, so whenever a patch get installed, the server may reboot. So whenever the reboot happens, we need our service to automatically start, or Python program to automatically start. Okay, or also it's not the developer who is going to deploy or run this or maintain this application, right? So it needs a very standard interface to start, stop, restart, check the status, all these things. Okay, because it's not a developer, it's going to be like a support person who is going to do this. So for all these we will need a standard mechanism to manage it. Okay, so that is why we need a daemon. So for creating this daemon or managing this daemon, we need somebody called systemd. In Linux systems, we have something called system daemon or systemd. So in Linux systems, you will see a lot of things with D, okay, at the end. So that is basically daemon. D stands for daemon. Systemd is the system daemon. We can call it as the master daemon or the initializer daemon in Linux machine. So this is the daemon that gets started first and organizes or manages the remaining daemons in the system. Okay, so we use this to create a custom daemon. So there is a definition for that. So there is a way to create a custom daemon, and once you create that custom daemon, then using systemd you can start, stop. Okay, so you can do the required management. Okay, so that is how we create and manage daemon. So let's see how to create. Okay, so I am explaining this daemon creation with the example of a Python program. Okay, but you can use this mechanism for starting or managing any other application. Okay, as long as you have a way to start that, a binary to start that particular application, you can configure that as a daemon, or you can create a daemon using that. Okay, so I'll take another video with more details of the internals of daemon, how it works, everything. So here in this video I'll be focusing more on how to create a simple daemon out of it. Okay, so the daemon file or the service file has most of the service file has the three sections. One is unit service install. So in the unit section we have description. Okay, so description, here we can simply put like a text description of what this daemon is. Okay, you can write your own description. I just put coders web service. So then after is basically, let's say if your daemon, your service or your program is dependent on some other daemon, okay, so or something else, so those dependencies you can create using after, before. There are multiple other arguments to it. So after means, I mean, after that particular one, this will basically after this particular service hours will start. Okay, so by default, I mean, you can keep network.target, but like let's say you have a database service, something called MySQL or PostgreSQL or something. So what you can do is you can manage the dependency over here so that the database will start first and then your program will start after that. Okay, start limit interval second. So this is basically like, I mean, the it's related to the start limit interval. So it's the time for like there, it's all associated with, I mean, I'll get into this topic in the while explaining the daemon part in the separate video. So there is configuration related to the restart. Okay, so restart equal to always, restart on failure. Okay, and also like, I mean, the number of restarts. Okay, and the time period between restarts, the time once you basically trigger the daemon, right, once you start or initiate the daemon. So what's like, I mean, the delay to start, all those, I mean, we can control using configurations. Okay, so for now what you do is you just think about, I mean, keep it as 0. Okay, so I'll explain this later in the next video. And then type equal to simple. Okay, type here itself, I mean, there are various options for type, but for your Python program you can keep it simple because there are something like fork, there are various options for type. Okay, so and next part is the restart. Restart means in what scenario it has to restart. So let's say always means, and whatever. So if your application or program exits, it always restarts. Okay, so it depends, you need to configure this based on your use case. So if you want to restart only based on failure, then you can, instead of always, you can keep on hyphen failure. Okay, so if under any circumstances if you want to restart, you can keep restart equal to always. Okay, so all these you can configure. Restart sec, it's basically like, I mean, the time between the restart. So whenever it exits, it waits for 1 second and restart. User is basically the user in which this daemon gets executed. Okay, so whenever this daemon starts, what will happen is the underlying application gets started as a specific user. Okay, if you don't specify, what will happen is it will execute as root. So if you specify user, then that process will be started as that specific user. So when you are configuring your Python application, always specify a user. The reason is, if you start as root, then that program will have like, it will be executed as a root user, and it is not the right way to do that because there are some security implications. Okay, because let's say if somebody gets access to the program, then they can execute commands on behalf of root user. Okay, so there are a lot of things associated with that. So that's why never ever run your application as root. Then exec start. So this is the place where we keep the command for starting your application. For example, your let's say you start the application python app.py. Okay, so the path to python and app.py, that full command you have to give here, and whatever dependencies, environment, file, load, everything you can keep it in a single line, colon, I mean semicolon separated. If you have multiple commands, you can keep those commands semicolon separated. Okay, otherwise what you can do is you can keep everything in a shell script and trigger that shell script using the exec start. Exec stop, in some scenarios you will have commands to stop, specific commands to stop some service. Okay, so in some let's say in Python application you may not have it, but in scenarios where you have a stop command, then you can use the stop command, so that whenever we call the stop, okay, so we use systemctl the service stop, so stop will trigger this command to stop that. Okay, so install wanted by multi-user.target, default.target, there are various options associated with it. So I'll explain this part in a separate video, but for now, for getting our Python application deployed, right, we just need this file to be modified and deployed. Okay, so let's get into the practical part. So I have created a separate user, non-root user called coder user 01. Okay, so first thing what we'll do is let's create a virtual environment here. Okay, so what we'll do is let's create, I'm using miniconda for Python in this machine, so I'm creating a virtual environment with the name web app. So that the reason why I'm creating a virtual environment is just so that we can have separate environments for every application. So this is always recommended. So whenever you deploy an application, always deploy it in a specific environment, so that it won't conflict with the packages used in the other applications. It will take a while. Yeah, so I'm just confirming. Done. Yeah, now the virtual environment got created, we can activate it. Okay, conda activate web app. So this is my Python program. It's a simple Python program. Okay, it's slash API, and what I'm going to do is I'm going to keep it in the port 9090. It's a simple Flask application. It needs Flask package. Okay, once you start it, it will start slash API, and the status access is this JSON is what you will get it. Okay, this is a get method. We have not specified the method. Methods equal to get. Okay, so that this will be just a get method. Okay, so what we'll do is we'll deploy this code over here. I'm just keeping the code over here. Okay, so we have web app, but we have not installed the dependent package Flask. Okay, let's install Flask package. So this will once you install Flask, I'm just showing an example. Okay, so in your case you may have a lot of packages and you will have it in the requirements.txt. So just for demonstrating this, I'm just installing it manually directly. It will take a while because yeah, so let's wait till the package gets installed. There is some problem with the network, that's the reason it's taking time. Otherwise this usually happens very quickly. It has to connect with the remote repository, PyPy repository, and then download. Yeah, now it's downloading. Okay, so there are the Flask package and its dependent libraries are all getting installed. Okay, so now it's getting installed. It's showing like successfully installed these packages, everything. We are just waiting for the package installation to finish. Yeah, so it's installed. Now let's test this program, Python app.py. Okay, so it's working. Okay, so now what we need is let's create the system service. Okay, so the location of the system service, where we need to create the system service, we need to create it in a location, specific location. Okay, and we need to create it as a root user. So only root user can do this system service creation, or a user with super user privilege. Okay, so whoever can, so the location is /etc system daemon. Okay, so this is the location. Inside that we have folder system. So in this location, if you go, so I'll repeat the location, it is /etc systemd system. So in this location, if you see, there are a lot of other services running. Okay, so these are some other services that I installed in this machine and that got created by default. For example, let's review the GitLab run service. Okay, so this is something that I have installed recently, and here if you see, we have unit. Okay, unit, it has description, after network, service section is there. Okay, install is there, right? Restart equal to always. So it has a structure similar to what I have discussed. Okay, and if you see the exe start, you can see the complete command. It's like a long command, and this is what gets triggered when we hit the start. Also, it has something called environment file. Okay, it is basically pulling something from this environment file as well, right? So if you have so that's why like there are a lot of other options within this systemd file. So what we will do is we'll create something similar for our web app. Okay, so let's see, if you see the name GitLab runner.service, right? We'll create a file nano web app, okay, service web app.service or coders web app. Coders web app.service. Okay, so this coders web app is the name, service is like, I mean, the dot service is the extension. Okay, so let's open this. Let's now frame the entire contents. Okay, so description as discussed, coders service after net.target. Okay, type simple always, and then the user that we are going to use is coder user01. That's my user ID. Okay, exe start is tricky. So what we need is we need to find out the command to start this. Okay, how will we find out? First we need to go, so su hyphen let me get into the coder user01. So right now if you see the virtual environment here is base, I need to activate, we need to activate our virtual environment. Second thing is which Python. If I type this, you will see the location that points to the virtual environment's Python. Okay, so this points to home, coder user01, miniconda 3, envs, web app, Python. So this is the location to my Python. Okay, and because corresponding to the virtual environment there will be a Python binary. Okay, this is the location of the Python binary within my virtual environment. Now let's figure out the location to the code. Okay, code is within this location, right? Let's verify the location. So it is home coder user01 app. Okay, so that means the location is this one, right? Code is located in this location and the Python executable is in this location. So what we'll do is we will frame a command first cd to this location, because in your case you may have a configuration file, lot of things will be there, so it's always better to be here in this work directory. Okay, then what we'll do, we will execute this, okay, app.py. Okay, in this way what will happen is it will get into this directory. Now you don't really need to load this particular virtual environment. Instead you can call that virtual environment's Python by referring that binary directly and app.py. So in the exe start, what we'll do is in the exe start, let's go back, nano our coders web app service exe start, I'm putting this entire command. Okay, so this has two commands, one is cd to this location, second this entire app.py. So we can do another thing as well, so we can keep everything in a shell script and trigger that shell script from exe start as well. So let's save this. So once you save this, we need to reload the daemon service systemd. Okay, systemctl daemon reload. Okay, so the command to reload, so once you make any additions or modifications to system services, so that means if you add a new system service or if you modify a system service, you need to execute this command systemctl daemon reload. So this will reload all the daemons, okay, or daemon configurations. Now if you see systemctl, okay, start. Okay, so what was our service name? It is coders web app, right? So let's try to start this coders web app. Okay, now we have started. Now let's see status. Okay, now you see it triggered, but it throws some exception, right? So you can see it's exited, right? So the exited reason, let's verify why. Yeah, we can see this error over here. So what we'll do is we will try to edit this file. Let's see what is going on. Okay, so as I explained, so we have used basically cd to the directory and then a semicolon and then do this command, right? So instead what we should do is we can execute or we can keep this entire thing inside a shell script and then execute that shell script. That is option number one. Second thing is what we can do is we can add a working directory. So what is the cd like home coder user 01 app? So this is the working directory where we have all our the Python program, the app.py resides, right? So in our case it is just an app.py, but in case of a larger application it will be the program configuration, so many other things will be there. So what we can do is we can add, there is another configuration to the system service file where we can add the working directory, or where we can set the working directory. So what we'll do is we will set the working directory over here like this. So working directory equal to, instead of doing the cd over here, we will just keep the working directory over there. Okay, and then we'll remove the cd command from here. Then now what we have is we have just the home coder user, the Python. So basically this is the Python inside the virtual environment app.py, and this is the working directory. Okay, so but the thing is, I mean, even if you set the working directory, it won't load the environment variables or anything inside the working directory. So if you have any use case where you have a lot of variables to be loaded, or you have some things to be loaded from the directory or some location, I would recommend using a shell script. Okay, so instead of calling directly the app.py or directly the executable, you create a script that loads the environment variables and then executes this. Okay, so that will solve the problem. So let's try saving this. Now what we'll do is we'll have to, as we have modified this file, we need to reload the daemon, right? systemctl daemon reload. Okay, so even if you are trying to start this without doing the systemctl daemon reload, the system will tell, okay, there is a change to the service file, you have to reload using systemctl daemon reload. So now let's try to restart this or start this. Okay, so what we'll do, systemctl start, then coders web app. Okay, so let's try this once again. Now we have triggered the start command. Let's check the status now. Now you see it started. You can see coders web app service. You see a green color, that means it is running. Okay, so you see it is active status, it's active running. Process ID is this one. Okay, and you see the logs over here. Okay, so I have started it just using the basic Flask, using the default web server like app server inside this. So but in case of production, you'll have to use a production WSGI, something like Gunicon or anything. I'm not going to get into the details of the program. So the goal is to explain system service, right? So you can see the application running over here. Okay, so now similarly, so this is running. To stop the service, what we can do, stop. Okay, so now let's check the status. You can see active status, inactive, and previously there was a green color over here, right? So the green color, now you don't see that green color. Okay, it is black right now. It is just, there is no activity color over here. Active, inactive, dead. Okay, so it will show like when it was inactive, and it shows like killed. Okay, so in the same way again we can start the service. Okay, and systemctl enable this coders app. It's already enabled, I have enabled it, but if you do this, what will happen is when you reboot this machine, this service also will get started automatically. Okay, if you don't enable this one, what will happen, if you reboot the machine, the service won't get automatically started. But if you enable this, it will be an auto start when the OS starts. Okay, so that in that way you don't have to manually start application. The system will take care, the system D or the system daemon will take care of starting this application by default. So this is like, I mean, this is one of the activity that you need to be aware as a developer while deploying this applications. I hope this video is useful. So if you have any questions, comments, feedbacks, anything, feel free to comment below this video. Thank you very much for watching this video. Have a nice day.